Good day, everyone. This is Teacher Haji again. Today, we're going to discuss all about science. And the very first topic that we're going to discuss is all about scientific method. I know every one of you is familiar about this topic, okay? But of course, we're going to recall it for us to master it. Okay, I'll be sharing my screen. All right, there you go. Our lesson one is the scientific method. All right, the objectives that we have here is we need to describe the steps of the scientific method and apply the steps of the scientific method to different scenarios. First, we need to define first what is scientific method. Scientific method is a series of organized steps that are taken to answer a question or solve a problem. So we have the step number one, we need to make observations. 2, state the problem. 3, collect preliminary data. 4, formulate hypothesis. 5, test the hypothesis. 6, collect and analyze data. And 7, draw a conclusion. Okay, let's take the steps one by one. Okay. For number one, make observation. In here, of course, observation is a way of acquiring information using the 5 senses. And through the use of 5 senses, we recognize properties like color, texture, odor, and shape, and many more. An observation can be qualitative and it can be also quantitative. When you say quantitative observation, this is a numerical value obtained from measuring tools such as ruler, thermometer, and balance. And when you say qualitative observation, these are non-numerical values. These types of observation is mainly used the 5 senses. Okay, and number 2, we have state the problem. In here, observations generally lead to ideas. However, for observation that requires explanations, these observations leads to questions. Okay, you need to define the problem that you want to solve or know, and then the problem is usually in the form of a question. And then, of course, number 3, we have collect preliminary data. Once you know the problem that you want to answer, you should read about it. Like, for example, you can surf the internet, you can go to the library, you need to read books. These sources should be reliable. You should know if it's their information that they are giving or feeding in their web, if it's reliable or it's true. Okay, you need to analyze the facts and data that you collect and look for trends or pattern. Okay, that's for number 3. And for number 4, you need to formulate a hypothesis. Okay, after collecting the necessary information, a possible answer derived from the collected information is formulated. All right. When you say hypothesis, this is an educated guess that may lead to a possible solution to the problem. It is commonly stated as a cause and effect relationship, making it testable. Right, that's for number 4. And of course, we have number 5, you need to test hypothesis. This is then to support the possible answer to the problem. This can be in the form of experiment. Okay, experiment is performed to validate the hypothesis. An experiment does not prove the hypothesis, but rather supports the hypothesis. Okay, in testing the hypothesis, a type of experiment called a controlled experiment is implemented. A controlled experiment is designed to test if a specific change in the condition you hypothesize would cause a change to another condition. This type of experiment is called a fair test. These conditions or factors that affect the outcome of an experiment is called a variable. Generally, there are 2 types of variables. Number 1 is independent variable. This is the value that is being changed or manipulated. And number 2 is, this is the dependent variable. This is the factor that changes relying on the change in the independent variable. And also, it is also usual for experiment to have 2 setups. A number 1 setup is we have experimental group. This is a setup that all possible variables are held constant except for the variable that is manipulated in the experiment. This is, of course, for independent variable. Next is number 2, a control group. This is not exposed to any conditions of the experiment and all other variables are held constant. Okay, the change that occurs or the effect of changing the independent variable will be a change of dependent variable. The results of the dependent variable in the experimental group and the control group will be compared. If the dependent variable increases as the independent variable increases, or the dependent variable decreases as the independent variable decreases. increases. They are said to be directly proportional. If the dependent variable decreases as independent variable increases or vice versa, they are said to be inversely proportional. Okay, and of course, we have here number 6, collect and analyze data. If you are done with the number 5, you need to proceed in this step. The data from the experiment will be either support or oppose your hypothesis. If it will oppose your hypothesis, that's okay. At least you made the experiment. Okay, just like in the observation, data gathered may be qualitative or quantitative. A table is primarily used for quantitative data. Data is arranged in columns and rows. Okay, the independent variable is usually shown in the left column, while the dependent variable is in the right column. For example, you are studying the changes in the volume of a gas. As you increase its pressure at a constant temperature and number of moles, the data set may be organized into a table. Okay. Right. And of course, graphs or charts may be constructed based on the raw data to visually present the data and analyze it better. Analyzing the data involves looking for trends or patterns in the changes of the independent and dependent variables. Statistics may be used to determine the relationships of the variables. And of course, there are examples of graphs that we can use. Number 1 is we have a line graph. This is composed of grid plotted lines that are used to show a comparison between two variables. The values of the independent variables are on the x-axis, while the corresponding values of dependent variable are on the y-axis. And the values may be plotted and connected with a line. Like for example, this one, the graph in your downloaded guide, they did not include it here in this presentation, but I'm going to show you later. And also we have a bar graph. This is another type of graph that shows data scaled into bars. And a pie graph, this is used to show fixed quantities that have been broken down or a combination of amounts that sum up to one bigger value. And of course, the last step in scientific method is you need to draw a conclusion. With the data gathered and presented visually, it will be easier to interpret the data to draw a conclusion. Okay, you should keep this in mind, this question: does the data support or invalidate the hypothesis? If the data supports the hypothesis, then the problem is solved. The study should then be shared with other scientists to spread the information. Other scientists may also work on your hypothesis to further support your study. If the data otherwise opposes the hypothesis, this does not mean that the experiment is a failure. Knowledge is still gained if a hypothesis is not supported by an experiment. If this happens, a new hypothesis can be made and another experiment may be designed. Okay. All right. So that's all for the scientific method. Again, let's enumerate the 7 that we have here. Right, we have make observations, that is step 1. Step 2, you need to state the problem. 3, collect preliminary data, formulate hypothesis, test the hypothesis, collect and analyze data, and you need to draw a conclusion. All right, thank you so much for listening about scientific method. If you have comments or if you have questions, just comment down below. Bye.